All right, so how do you determine the vertical asymptotes of a graph? All right, so what you want to do is you want to first simplify the rational expression. So to simplify it, we're going to factor. Can I factor anywhere? Here's just x, but here x squared minus 1. Now remember, that's a difference of two squares. So that's x plus 1, x minus 1. And so now that's how it's factored. Okay, that's all we can do for factoring. And so now, how do you determine vertical asymptotes? So once you're done factoring and simplifying, you set the bottom equal to 0. So what makes the bottom equal 0? So the VA is you set the bottom equal to 0. Okay. So I'm going to set the bottom equal to 0 for each of these factors using the zero product property. Okay. So you subtract 1, x equals -1, add 1, x equals 1. So my vertical asymptotes here are x equals -1 and x equals 1. Now you have to put the equations. Don't put -1 and 1 because that's implying it's point. I'm talking, and we'll see this when we graph it, it's the equation x equals -1 and x equals 1. It's going to be actually a vertical, it's actually going to be a vertical dash line, okay? And we'll talk about that later. Now, this one brings up a unique scenario on E. You factor the top and bottom. Okay, the top's already factored, but the bottom is x squared minus 1, so that'd be x plus 1 times x minus 1. All right, so what happens here? Well, x minus 1's cancel. So now, the vertical asymptote is what makes the bottom equal 0 from what's left over. So it's just going to focus on that. So x plus 1 equals 0. So it's what makes that equal 0. So I subtract 1, x equals -1. That's my vertical asymptote. I only have one vertical asymptote. Now, there's a question. What happens here? And I'm going to talk about this. I don't even know if this is in the directions, but I need to talk about it. We had a variable on the bottom that cancels. Whenever something on bottom cancels, when something cancels, that creates a hole. Okay, when something cancels, that creates a hole. Okay, so this graph's going to have a vertical asymptote in it, and it's going to have a hole. Okay, so the hole is going to be what makes this part equal 0. X minus 1 equals 0. So add 1, x equals 1. There's going to be a hole at x equals 1. Okay, so this one's going to have a vertical asymptote and a hole. Whenever we start graphing here in a moment, you'll kind of see what that looks like. Now, next, x minus 1 times divided by x squared plus 1. Now, x squared plus 1, we tried this game earlier. What can it factor? This can't factor with real numbers. It's a sum of two squares. So you can't factor with real numbers. We played this game earlier. What makes that equal 0? We tried it earlier, and then you subtract 1. X squared equals -1, square root, plus or minus 1i. There's no values that can make that equal 0. There's no real values that can make that equal 0. Let me rephrase it. There's no real values that can make that equal 0. So in this case, there's no vertical asymptote. Okay. I'm going to make a note here because there's no real values of x that makes the bottom equal 0. Okay, so there's no real values of x that make the bottom equal 0, so there's no